Hi there, my name is Ryan, and I operate a kiln and wheel repair business in the DC area, and I also run a small glaze business, and I teach classes and stuff. I do a lot of very short form videos on Instagram on how to fix things and some basic things about glaze chemistry, but I am in the middle of a project that kind of necessitates a longer video. So today I am going to be refurbishing and replacing some bearings in at least one mid-70s Shimpo RK2 wheel. And these are really, really cool pieces of equipment. I love them. They're absolute tanks. They've lasted, 50 years so far, and if you care for them well, they'll probably last another 50 years. So I just figured I would go really in depth about how to fix one of these things up. So first things first, we should probably talk about how one of these wheels works. They're really cool. They were very common in the time before inexpensive computers became readily available. So this has what's called an AC motor in it, alternating current. So most of the motors in your house are AC motors. Any fan that you have, your HVAC system probably runs on an AC motor. If you have a blender, a hair dryer, a drill that isn't a battery-powered drill, all of those things probably work on AC motors. And the really cool thing about an AC motor is that it's kind of a dumb motor. You plug it into the wall and it works based on the electricity that comes right out of your wall. This is very different from a DC motor, which requires some relatively simple circuitry to get it to spin. So if you take alternating current AC out of your wall and you try to plug it into a DC direct current motor, it's probably going to burn the motor out. It's not going to work very well. So a couple of pros and cons of both of these types of motors. An AC motor really only spins at one speed, and it'll spin at a speed that is kind of determined based on how quickly your current is alternating in your wall. So in the United States, we have 60 hertz current, which means that our current alternates 60 times per second, where it's pushing and then pulling an electron back and forth across a circuit. So that's great if you only have one speed that you want to spin at. And you might see why that might be a problem for a pottery wheel specifically. DC motors really excel at multiple speeds. So you basically, with a DC motor, you're sending little pulses of direct current into the motor using this circuitry, except that circuitry back in the 70s was a little bit more expensive than it is today. So today we tend to use DC motors in our pottery wheels because those little tiny computers have become somewhat inexpensive, relatively speaking, and it's really easy to control a DC motor now. But back in the 70s, an AC motor made a lot more sense. So how do we get this thing to spin at a different speed than just the one speed? We have to use a mechanical means of doing that. So inside of here, there's what's called a ring cone drive, and I'm going to go way into depth in that in just a second. But before I get into depth on that, I want to talk about one of the major things that I'm repairing about these wheels. So I'm going to turn this on, and if you listen, you're going to hear this motor spool up. And it's right away, it's spinning at its maximum speed, about 1800 RPMs. Now it's very loud. And it's very loud because it needs new bearings. And that's one of the things I'm going to replace today. So let's turn this upside down and take a look at what's inside of here. So I've got this pottery wheel turned on its left side. And if we look inside here, here's our AC motor. And again, AC motors are really simple. The only control that we have for this motor is this switch. When I turn that switch, this motor's on. And what it does is it spins this cone down at the end here, and it spins it at a constant 1800 revolutions per minute. And you can even hear as I just spin it with my finger, it's real squeaky because those bearings have gone. And so this cone, if the tip of this cone is touching this ring right here, and when I spin this ring, it's spinning the wheel head, right? So the tip of that cone, if it comes into contact with this ring, the very tip of this cone, if it's spinning at 1800 RPM, that's a pretty small circumference there. So 1800 revolutions per minute contacting this ring, this is going to spin relatively slowly. Now, if I slide this whole motor forward so that the back of this cone, the wide part of this cone, is touching this ring, that's a much larger circumference. So it's still going to spin at 1800 revolutions per minute, but that 1800 revolutions per minute is a much further distance around the circumference of this cone, and this ring is going to spin a lot faster, and our wheel is going to spin a lot faster. So the way that this wheel works is we've got this foot pedal on the side here, and as we tilt this foot pedal forward, it slides the whole motor forward along this rail system that's down inside of here. Alright, so I've taken us over to a different room, and this is actually a different wheel. I've got 3 of these things right now that I'm working on, and on this one I've already removed the motor from this wheel down here, which is going to allow us to kind of see this mechanism that slides the wheel back and forth, or the motor back and forth with, pretty easily. So I've got the foot pedal up here, and here's this plate that this motor was attached to, and when I move this foot pedal back and forth, it moves this linkage, this guy right here, it moves that back and forth, and that, I'm going to move my light around a little bit, is attached through another linkage to this plate. And this plate is running back and forth on this bar that's back in here, which, let me move the light around again. There's that bar, and I have the light in my mouth now, but that bar moves back and forth through this linear bearing right here, right? So that's kind of how this works. They're really simple and really cool and really interesting, and I'm going to go over some specifics on tearing down specifically the motor today, but also just getting the motor off of things and cleaning and lubricating some of the stuff inside of here. So the motor itself is held on with 4 bolts. There's this mounting plate down here, and there's 4 bolts that go through the plate that slides back and forth up here. And you'll notice there's a whole bunch of other bolts on here too. Pretty much every single bolt on this thing is some kind of adjustment to be able to change the way that the motor interacts with this ring right here. So you'll notice that this bolt goes through a slot. So if I undo this, I can slide this plate back and forth in a way that will adjust where the tip of the cone is that's on this motor and how it impacts that plate, right, or it impacts this ring right here. So the more pressure that you put on the ring, the harder it's going to be to change your foot pedal, because, you know, there's going to be a lot of friction between the cone, this metal cone that I've already removed, and the tip of the ring right here. But also the more torque you're going to have while you're throwing. The other thing that's kind of a downside here is that the more pressure you put on this ring, the faster you're going to wear this ring down. And these rings are incredibly difficult to find now. I actually have 3 brand new ones in my possession, and I'm going to try and find some way to cast mother mold from one of those rings, and then cast some subsequent rings using that mother mold, so I can hopefully produce these in the future and potentially even sell them someday, because Shimpo no longer produces them, and they're very, very useful and hard to find things. So you don't want to wear this down too fast, because if you're pushing this motor up against this ring too hard, you're going to wear it down more quickly. Let's see. So the 4 bolts that we're holding this thing in, it might not be a bad idea to pay attention to where those bolts mounted onto the motor itself. You might want to take some, make some measurements about how those impact, or how those bolts go through these slots and where they go through these slots, just before you take this motor off. I personally didn't, because I'm going to be adjusting this whole thing anyways, so I'm going to want to be able to slide it back and forth while I tighten and loosen different aspects of the motor. But yeah, it's not a bad idea to keep track of where things attach to other things. So I've pulled the set screw out of this cone here, and I blasted some PB Blaster down in there. I haven't waited very long, but I'm going to go ahead and give this a shot. So I've got 2 pry bars in here, and I'm just going to attempt to separate them. Ooh, I got somewhere with that. There it comes. Beautiful. Okay. Make sure I don't want to drop that down on the floor. Whew, cool. So after you have the 4 bolts removed that detaches this plate from this plate, you're going to have a motor that's free down here. And it's going to already have this guy on it. Now, I took a video of when I removed this one, and it was surprisingly easy. A lot of the time, these things are really difficult to remove. But the way that you remove these is there's a little set screw that sits inside of there. So it's a kind of a long set screw, pulls out there. And after you get that set screw out, you can pull this guy off. Now, a lot of the time they're really rusted on. So you're going to want to drop some kind of like rust penetrator or a penetrating catalyst in there. I really like PB Blaster. This stuff is amazing. But if you jam it inside, like after you remove the set screw, if you drip some inside of there and let it sit overnight or for several days, it'll eventually become a little bit more easy to remove. Now, if you drop this stuff in here and you've tried prying it off using the video that I just showed of me pulling this guy off of here, and you still can't get this thing off, then you might want to try grabbing what's called a slide hammer bearing puller. And what that does is it'll have some little jaws that'll come down around here, and those jaws will have a long pole on the back end of them, and that long pole has this weight, and you slam it up, and as you slam it up, it pulls on this guy right here. They sell them at Harbor Freight for like 50 or 60 bucks, and you can probably find one on Amazon, but I like Harbor Freight anyways for tools that I'm only going to use a few times in my life, so I would probably just grab the Harbor Freight one. But yeah, so that's kind of the first specialized tool you might need. Other tools that you might need that I forgot to mention so far, because these are very old Japanese machines, you might want to have a set of metric, just basic mechanics tools. So I've got a 15 and a 13 box wrench, and just a bunch of different little wrenches and such. I think I've needed so far a 10 millimeter and maybe a 7 millimeter and a 13 millimeter. And this guy came in really handy because I couldn't get my socket, my 13 millimeter socket, up above this plate and have it fit well. So you're definitely going to need at least one 13 millimeter open-ended wrench. All right, so let's get to the motor itself. So if I spin this guy, and I'll be quiet in a moment here, but you'll be able to hear that the bearings themselves are quite loud. So they're like really squeaky inside of there. And I need to open up this motor and replace the bearings inside. Motors are fairly sensitive bits of equipment. When you open them up, you need to be somewhat careful and also pretty forceful, because it's going to require a lot of force to remove some of these components from this motor. But before you get into that, be aware that there's a whole bunch of copper wires in there, and you really don't want to touch those copper wires because they have a very thin coating on them that prevents them from conducting electricity into each other. And if you scratch away at that coating, you've basically ruined the motor. So you got to be really careful once you open these things up. But the first thing I'm going to do is I'm going to remove these 4 screws, and these 4 screws are going to attach. They're going to go through these holes on the back plate of the motor right here. So these are big, long machine screws that go all the way through. And then these guys are just Phillips head screws on here. Big, long screw. Big, long screw. One thing I haven't mentioned, obviously, don't do this while the wheel is plugged in. Never ever work on any equipment that's live. There's really no reason to do so. So, just be warned. There we go. Okay. So, we've got those screws pulled out of that motor. And now, if you look, there's a little slot on the front and back plate of the motor to slide a flathead screwdriver into. There's one there and there's one there. I usually find that the back end is a little bit easier to pop off than the front, just because there's less going on back here. But if I slide a flathead in on either side, there we go. You can kind of give that flathead screwdriver a twist, and it'll very, very slowly start to back this guy off of here. Now when this comes off, there's a couple of little things in here that are going to want to spring out. So just keep that in mind as you start to loosen this guy, that you don't want everything to go flying. There we go. So there's these two little, or usually there's a little shim inside of here. There isn't a shim on this one though, that's interesting. So that's kind of cool. So here's one of our bad bearings. Let's have a closer look at this. So when you're looking at a bearing on any motor, you can look really closely right here. I don't know if that'll come through on the camera, but it says 6202V. And if you go online, you'll be able to find a 6202V bearing, and you'll be able to pull this off and put a new one on. Here's the copper wires in here that we don't want to touch. All of this stuff in here, this is kind of the mechanism that allows the electricity to get into the wheel. So we kind of don't want to mess with this stuff if we can avoid it. Let's see. I'm assuming there's brushes up inside of there somewhere, but I'm actually not seeing anything. So I'm not gonna get in anywhere I don't need to get in. I'll probably take some compressed air and blow into this whole area to just get as much junk out as I can. But because of the sensitivity of the stuff that's down inside the motor, I'm not gonna go down in there if I don't have to. All right, so I got the front plate on the motor somewhat separated from this casing, and it's wanting to pull the armature, which is the whole, fixture that goes through the motor and turns, spins. It's wanting to pull that out because this front plate on the motor goes around the front bearing, and that front bearing is slipped over this shaft pretty tightly. So we have to kind of pull this whole thing separately, and we're actually going to get into our first real specialized tool, which is a bearing puller. I'm going to put you guys down. So the way that this tool works, this is a 3-jaw bearing tool puller, and I picked this up also at Harbor Freight. I think it came in a set of 3. I have no idea how much it cost, but it wasn't terribly expensive or anything. It's Harbor Freight. But so I'm going to get my 3 jaws wrapped around the part that I need to pull, and then once I've got that there with my 3rd hand somehow, I'm going to start to kind of get a little bit of pressure on this center shaft. By spinning this center shaft to the right, I can slowly put pressure. Okay, so it's all set now. So ideally you want to kind of center that little point in the center of the shaft here, but it is a little bit off center. It'll probably be fine. This is not a really tough pull. If I were really pulling really hard on this one, which I don't think I'm going to have to do, then I would be much more careful about getting that centered. So those jaws are attached to this ring, and if I hold this ring steady with like a screwdriver while I spin this guy to the right, what's going to happen is it's going to push down on this center rod and pull out on this plate. Okay, so I'm going to jam a screwdriver through here just to hold this bit steady, and then I'm very slowly going to start to turn this center shaft to the right, and as I do that I can already feel this plate sort of loosening, and if you watch right here you can see that it's slowly backing off of that shaft. And pretty soon here it's going to pop off real easy and everything's going to come loose. thought it was. It's still really on there pretty good. Any day now, this guy will pop off. There we go. All right. Let's see what we got. So there's that front plate. There's a little spring that kind of holds everything together. We'll make sure that we keep that in there. And then here's our bearing. Now, ooh, this one sounds terrible. We are going to pull this bearing with the exact same tool that we just used for the front plate. So I'm going to wrap these 3 jaws around the bearing, and then I'm going to try and center this guy in the middle here, and I'm going to start to tighten. It is worth noting that this will destroy your bearing, just FYI. Because those jaws are pushing into that back surface there, and they're ruining the seal on the back of the bearing. So make sure you have a replacement bearing ready to go when you do this. I've also heard that it's a really good idea to lubricate these threads frequently because of the amount of pressure you're putting on them. You can wind up with issues with stripping those threads out somewhat easily, apparently. We should be getting close to this thing popping off of here soon. There it goes. Okay. So there's our old bearing. Oh, I can feel how rough it is. It's so bad. Cool. Now we got to do the one on the back. In this case, I'm actually gonna need a different bearing puller for this one. Give me 1 second. Okay, so this is my normal bearing puller, and the jaws are too big to fit between the bearing and this somewhat sensitive electronic component up here. See that? It won't get back behind there. So I have this other bearing puller, which is kind of a low profile bearing puller. And so it's only got 2 jaws, and they're pretty flat. They've got this big surface area, but they're nice and skinny, so I can get them back behind my bearing without causing too many issues. But otherwise, it's pretty much the same thing. There we go. Okay. That there. Find a wrench that'll go over the back, and as I start to tighten this wrench, you can see that the bearing itself is going to start coming off. There it goes. Okay, one more bearing down. I just blew this whole thing out off camera. You'll have to excuse my my not putting that one on camera, but basically I just have an air compressor and I blew the motor out here. I have a kiln and wheel repair business, so I keep a whole bunch of bearings on hand. This one uses 6202 bearings, and let's see, let's pull these guys out of here. So here's a brand new 6202. And this guy is going to sit really tight on this shaft. And anytime I have 2 metal pieces that are going to go together that I might want to remove someday, I like to use an anti-seize lubricant to make sure that I can someday remove these from each other. I'm not sure exactly how this works, but if you've got 2 different types of metal coming together, they're more likely to corrode together, especially if they're 2 different types. And I think that this stuff just prevents that galvanic corrosion that you can sometimes get. And you don't need a whole lot, like really just a tiny bit is all you need. And this will just make it easier for the next person 50 years from now to replace these same bearings. Okay, so we're gonna get this started. And most likely I'm gonna need to grab a block of wood and a hammer in order to kind of pound this guy on here. And I'll be right back. So that's very loud on camera, so I haven't been doing this on camera. But basically, you want to get the front of the shaft of the motor up against something heavy. So I've got it up against the frame of the wheel. And then you want to get a little block of wood to protect your bearing, and then you want to give it some solid taps. And it'll slowly start going on there. It should be a really tight fit. That's good. If you're real fancy, you can like heat your bearing up and cool your shaft down, and then it should slide on real easy. But I don't want to do any of that, so we're just going to kind of slam it on there. Alright, so this is the top plate of the motor, and I got the bearing jammed into the top plate here. And I used more anti-seize in between the bearing and the plate, and I also put some anti-seize on this shaft. So now we're actually going to use this plate to shove this on here along with some clamps. And it is somewhat important that when we look through here, we're going to look up along the top, like right here. You can see that there's a space for one of those screws to go through. And those screws have to line up with these holes, right? So it's like slightly important that you get this all lined up right. This motor, it's kind of funny. I can tell which side was down because of how dirty the outside of this motor is. So this side faces down, and when the motor is mounted into the case, this side is down. So let's see. We're gonna look for where these holes are, and then we're gonna line up our bottom there. And then when we look down through these holes, we should be able to see our screw hole down on the end there, and that should line up just right. All right, so got anti-seize in between the plate and the motor, anti-seize between the bearing and the plate, and the bearing and the shaft on the top and bottom. I got these holes lined up, and if we zoom way in on here, maybe not, we might be able to see. There it is. There's a little tiny bit of light. Can you see it back through there? So that's where that screw is going to go through. So we made sure to line up this hole with the hole back here with the slot that goes through, this hole with the hole back here and the slot that goes through the middle of the bearing here. And then I used these clamps to kind of get everything together. And everything did kind of want to slide around while it went back together, but that's okay. This next part is really finicky all the time. I've never had this go easily, so I'm not going to do this on camera. But basically, we're going to get this screw all the way down through and try to get it to go through the hole on the back end and thread it into that hole. One of the best things that I've found for this is if you shove a needle tool down through the end here, you can feel the end of the screw and kind of manipulate it the right way until it goes through that hole. And that works a little bit, but it still takes like 10-15 minutes. So I'm not going to do this on camera because I got 4 of these screws to do it. It's going to take forever. All right. So one of the most important things, in my opinion, is getting anti-seize between the cone and the shaft. And so I put that on pretty liberally because this is by far the most difficult part to remove during the process, and we want to be able to remove this again in the future someday. So I got anti-seize in there pretty liberally. This is a pretty soft tip right here, so when you're putting it back on, be sure to have something between this and whatever you're using to bang it on there. Don't just like slam it with a hammer, because this is your low speed down here, and if you knock that off, it's going to make your low speed on your wheel kind of weird. So like put a piece of wood there and then slam the wood with the hammer rather than slamming the cone itself. Other things, I also put some anti-seize before I put the set screw in and tighten that back down. And admittedly, I've already turned this on to make sure it works, but much quieter than it was before. No squeaking, unlike the one in the other room. Yeah, and that's kind of most of what there is to it as far as refurbishing just the motor part. There is, of course, a lot of stuff up in there that can be refurbished, This wheel doesn't need any of that. In general, with the rings, try to wait until you're really at the end of the life of this ring before you repair them. This one's in like truly phenomenal shape, so we're definitely going to leave this one be long term, just because it's really done nicely. Other things. There's two more bearings. There's a big bearing up above here that you can remove by pulling the wheel head and pulling that off, but this doesn't make any noise. And there's another bearing up above here that you can also remove and change. And all of that stuff you access by removing the bolts that are on the top of the wheel. So you would have to remove the wheel head itself, which again is a set screw here. And then there's 4 bolts here, here, there, and there, and then 4 more bolts through here, and that loosens all of the stuff that's on the top part of the wheel up here. So that's more or less what there is to it. Other things involve changing out switches and wiring, which I'm not going to do on this video because none of this stuff needs done. Just, you know, general metal refurbishing. I'm going to clean all this up and, you know, probably steel wool anywhere where I've got rust up in here, and then use some kind of a rust sealer and then a paint on top of that. And yeah, overall these guys are very, very simple. This is by far the most complex repair is this one, and everything else is kind of not nearly as difficult as getting bearings inside the motor changed, and even that isn't too bad. So hopefully this was useful to somebody. Anyways, bye.